The dimensions are 2.75 meters in length, 1.9 meters in width, and 0.97 meters in height.
For the foundation of this workbench, I used 22mm medium density fiberboard MDF. To ensure durability and stability, I reinforced the underside with 2x4s along the sides and added cross bracing in between for extra structural support. For the workbench top, I used 22mm medium density fiberboard MDF paired with a 16mm melamine sheet underneath for added stability. Between the top and bottom layers, I reinforced the structure with 2x4s, ensuring the entire build is solid and durable. Twelve 75mm lockable caster wheels fully support the structure's load, even with all machinery mounted, ensuring smooth and secure mobility. The wheels are arranged in 4 rows along the length of the bench, with 3 casters per row for optimal weight distribution and stability. All layout and configuration options were carefully considered to ensure maximum practicality and optimal use of each machine. The planning process involved a thorough brainstorming session, during which every piece of equipment was physically placed on the bench and repositioned multiple times to determine the most functional arrangement. Once the ideal layout was finalized, each machine was securely installed onto the workbench. All electrical wires and cords have been carefully routed through protective tubing beneath the workbench surface, leading directly to the designated power supply sockets. Provision was also made during this phase for the installation of additional machinery at a later stage, such as a wood vise, band saw, small planer. The miter saw was installed with precision and leveled to match the 2 of the workbench. A spirit level was used to ensure the saw's top surface aligned exactly with the bench surface, providing a continuous and accurate cutting plane. Flexible hardboard panels were fitted along both sides of the saw, positioned between the bench top and the saw's base. This installation detail serves different purposes. It creates a clean, professional finish and prevents sawdust from accumulating in the cavity beneath the saw. During the planning stage, it was determined that the router faceplate would be utilized as a guiding reference for cutting long pieces of wood with the miter saw. This approach ensures consistent alignment and accuracy across extended cuts. The procedure was validated through testing and shown to achieve effective results. During the planning phase, provisions were made to remove the router faceplate and lower the router bit when cutting large wood sheets. This adjustment creates additional clearance, allowing oversized panels to slide smoothly through the cutting area of the miter saw. 2 additional 1-meter rulers were countersunk into the workbench top, positioned on opposite sides of the table saw to provide precise measuring references. For the interim, a long, straight plank was used as a makeshift guiding fence. It was securely clamped to the workbench and served the purpose perfectly. A cost-effective solution was implemented to raise and lower the router bit. A standard car jack was mounted beneath the router motor, fitted with a handle that could be rotated left or right to smoothly adjust the bit's height. Holes have already been drilled to accommodate a sawdust extraction system for each machine. The system will be installed at a later stage. For the interim, panels of hardboard have been screwed together with concertina hinges to form a shield that catches most of the sawdust and wood shavings. The shield is flexible and can be easily repositioned on the bench top. Dust masks and other personal protective equipment must be worn to prevent inhalation of dust. All electrical equipment can be switched on and off directly at the surge and overload protected multi-plug power supply, which is positioned on one side of the workbench. There is ample storage space beneath the workbench top. At a later stage, shelving will be added to create a more organized interior, where all specific machinery tools will also be stored.